This is going to be fun. I'm going to fall over. Sweet. Thanks a lot. Last time I was in Copenhagen, actually I think, Allison, you were here too. That was the last Ubuntu summit that we had in here. Well, it wasn't the last summit. They had the Oakland thing. But anyway, so now I'm just reminiscing. Turns out this talk is going to be a lot about me telling stories about myself from the past. So if you want to go to lunch early, probably now is a good time to escape. A couple quick notes about the talk in general. The slides are online. If you just love them so much that you want to go home and show them to your kids or your dog or whatever, or you just want to print them out and have the dog eat them, that's acceptable. I've got a Twitter thing that you can do those sorts of things if you're into that. The slides are also Creative Commons licensed, so if you want, I can't imagine what you would do with them, but you're welcome to do that. They're in Git at git.inaugust.com. There's a little tiny link that you probably can't see in the corner down there. So on the off chance that you're like, wow, I really want to git clone these slides, and also it turns out Monty's entire website, you're free to. Go nuts. Again, I'm not sure why, but that's it's not for me to make that call. That's for you. So the subtitle of this talk is actually probably this. I'm going to talk a bit about Unix for those of you who aren't as maybe caught up on some of the lore or some of the background, and we'll talk about how that might relate, or I might not. I might just say random words. So I'm Monty. I work in the CTO office at Red Hat, focusing on CI, CD, and automation tasks. Specifically, there's a project we work on in the OpenStack context called Zool, which is the thing that drives our CI and gating infrastructure for OpenStack, which we just rolled out the V3 version of. Woohoo! The new version is Ansible-based, in fact, so I do a lot of things with the Ansible people. I'm more relevantly here. Been around OpenStack for a while, as said. I work on the team that runs the developer infrastructure for OpenStack, so we do all of the servers, all the tools that the developers use to work on OpenStack. I'm also the PTL of a project called Shade, which is a client library for OpenStack. So if you want to talk about all the ins and outs of consuming the OpenStack APIs, I know way more than I should about that, and I'm happy to chat about that topic. I am, I think, currently technically still on the technical committee, but that's about to be over because I did not run for re-election this time. I also, this last time, did not run for re-election for the board of directors because, there's just only so much of your life you can spend in meetings. So hopefully the next set of technical committee people, they get to have all the fun that I've been having. So good luck to all of you. I also started the developer infrastructure team and was the original PTL of that. So there are many things that I do currently and many things that I used to do, and I was like, wow, I don't need to do this anymore. In terms of how long I've been around OpenStack, if you go to the OpenStack page on Launchpad, you might see some of my handiwork. So it's I've been around for a while, which is fine. 2010, 07, 06. That's just a long time ago. Wow. In talking about cloud, I want to talk a bit about cloud and sort of cloud native applications and what cloud means. And I wanted to step back a little bit before cloud, because this is all sort of, in my brain, stems from the sort of the original Google papers that freaked everybody out, especially in the server selling industry, where Google came out and said, you know what, we've just got the crappiest servers laying on shelves, and that's better because we don't have to spend all the money on them. Ultimately, when you have tons of servers, at any given point in time, you're going to be guaranteed to have a percentage of them in failure mode. So why would we spend excessive amounts of money on fancy, expensive Sun boxes when we can just go buy crappy commodity motherboards and not even put them in cases and just stick them in some cardboard. And that, in a lot of ways, changed a whole bunch about the industry. So there's a link here to the original paper. It's interesting to read. It's also amusing that 15,000 server number was a really big deal back in 2003 when they published that paper, and now it seems kind of cute. It's like, wow, you had 15,000 servers. Good job, Google. But that sort of changed a lot of things about how we think about this the space in general, and we weren't really thinking in terms of cloud at this point. It was just computers trying to do web things. I think we were still using the word Web 2.0, or we might have just been starting to use the word Web 2.0. I feel really old even knowing that term, but this is what, almost 15 years ago. So the kind of outcomes of that and things that became very sort of regular standard knowledge for people doing high-scale website, web traffic things is the things that have become very commonplace to us now. We all do this constantly, right? It's assume failure. Everything's going to fail. Don't assume that you can build a server that's never going to turn off, right? It's gonna crap out. The fans are gonna die. The power supply is gonna die. The disks are gonna, just rot. It's gonna go terrible. So because of that, use cheap servers so that you can have multiple of them and make your software resilient on top of that. And ultimately, this leads to a model of scaling out rather than scaling up. I had a fun conversation at a consulting gig with a guy at MySpace back when MySpace was the big the big thing, and we got into an argument because I was telling him about the general pattern that we had in scaling MySQL things about getting as much data out of the database or as much processing out of the database as possible because it's the hardest thing to scale. And he was like, "No, what are you talking about? The database is the easiest thing to scale. You just buy a bigger server." And I'm like, "I'm sorry, my friend, you are not thinking big enough yet," as is clearly the case given where they went. In any case, so this leads to sort of my my personal favorite architecture for doing distributed systems, which are shared nothing systems. I got into a fun argument with somebody at a MySQL conference many years ago with a talk titled SAN as a single point of failure. The SAN people didn't really like me, but they also didn't have a really good question when I asked them about the 4-day rebuild time after the SAN operating system had crashed. So it's kind of tricky. So you want to make sure that you can have lots of elements in your system and have them independently fail and have that not take your system down. All of the things are going to fail all the time, so plan for that. So I've mentioned it a couple times already, told you sort of who I am now. So I used to work for the startup company based out of Sweden. You may or may not have heard of them. Something about databases, I don't know, and dolphins, I think. Databases of dolphins. I was in the professional services team. I focused on high availability, scale out engagements, and also our MySQL cluster product, which is a telco 5.9's database that was developed at Ericsson. So it's all sorts of good stuff. Excuse me, Nokia, Ericsson. I can't remember. Ericsson, I think. Anyway, they didn't write it in Erlang. They wrote a different language to write it in that they then translated to C++. Never mind. It's data blocks if you're interested in old distributed programming languages. Anyway, I bring that up because I wanted to tell a little story, and also because I got to hang out drinking with Florian last night. If you haven't hung out drinking with Florian, it's a lot of fun. If you can make it 5 minutes into the conversation without talking about global politics, you've done a really good job. But it's always a fun thing. So back in the day, I was doing HA things for MySQL, and we focused one of our most common delivery things for HA at that point in time was a DRBD Heartbeat v1. It turns out a solution. Which is how I know Florian at all. We couldn't because Heartbeat v2 sucked at the time. Didn't work. And in fact, that is very much to the point of the amusing anecdote that I'm going to be sharing right now. The thing that I liked about Heartbeat v1, it was extremely simple. It did not handle more than 2 nodes, but for a DRBD cluster in 2007, you didn't need that because DRBD also didn't handle more than 2 nodes unless you wanted to risk data loss, which is kind of against the point of a HA data storage system. And it was very good at assuring that you could flip over a virtual IP between servers. And the best way to do this was to have sort of redundant heartbeat paths for it. So typically we would walk in and we'd walk up to the customer and be like, okay, so you got your servers here. I want you to go to the store and get a crossover cable, because this was before all the cables just magically could do direct connections, because I'm old. Get a crossover cable and plug it between 2 of the NICs. Actually, we want you to get 2 sets of NICs so that you can bond them together and have 2 crossover cables and plug them together, and you've got this really nice thing that there's no power path in that. It's a physical cable, and there's 2 of them, right? So it's the chance of that going split brain on you is pretty low. And then if you really want to get crazy, you can add a serial cable too, and you've got all these redundant paths, and it's also really low tech. It's like $5 to get that done. So we would do that, and it's very successful. Then you go with the customer and you like yank power cables, and they get excited, and they're like, oh wow, look at that, the data is still up in the database. It didn't go down, and it's all this great stuff. We had an engagement with a company who had their servers in a hosted data center from a telco that I will not name by name, and so we didn't have the ability to have hands-on boxes. It was all remote hands kind of thing. So you put in the tickets. We want you to set up these servers and blah blah crossover cables, et cetera, et cetera. They're like, yeah, totally. We've done that. We're all set, ready to go. So we go to do the rollout, and the first part of the thing is you have data on one disk, and you're replicating at the block storage level to the other disk. And so the first thing you have to do is sync the data over the network, which is usually fine. It's a fine thing to do. Unless the data center techs didn't give you a crossover cable, and instead decided to just map a route in with their networking mesh for the data center, and to do it slightly wrong. So that what you wound up with was these 2 virtual cables that were inverted. So you had the one on this side thought it was talking to the one on the other side, and that one didn't know anything about because they'd done the math wrong. So essentially what happened is it caused their network fabric to broadcast ARP out for every single byte of block storage transfer that was happening at as fast as it could be read from disk. So their network mesh crashed itself, which was fantastic. And they freaked out because this is like a very, very large data center on the East Coast with a bunch of banks in it. And literally the entire network of the data center was just down. It took them about a day to figure out that when they had told us that they had plugged a direct cable in between, that they'd lied to us, which is always fun. Anyway, moral of that story is if somebody asks you for a crossover cable, and there's probably a reason that they wanted a cable and not the networking mesh. One other real quick thing on the MySQL note, there's a great interview with a bunch of the Facebook MySQL engineering team on Percona's blog. And I pulled this out of it. Somebody's like, MySQL, why, you're at Facebook. Wouldn't you guys made Cassandra? Like, don't you want NoSQL things? And Yoshinori, who is the smartest person I've ever met in my entire life, by the way, you should get drinks with him at some point and talk about baseball, which he's super into. His response is, it works really well, and also we understand it. We know how to debug it when it fails. It's simple, it gets the job done, and we haven't found anything that's better at it. And they look at all the things all the time. So from both of those, the sort of takeaways, the reason that I'm babbling about old war stories from the past is that simple is almost always better than complex. A single very hard to fail 1 meter network cable is very capable compared to an extremely complicated network mesh. for the task at hand of sending heartbeats reliably between two machines, so you can tell when the network has failed. Simple is better. Also, know how your software works, right? It's the failure modes that are going to kill you. If the thing works really, really well 95% of the time, but when it crashes, it's just like a complete disaster zone, it's not any good. Like it's useless. You can't use it, and you need to understand what the effects of something failing are going to be, more than anything else. If it gets the job done really, really quickly, most of the time, maybe it's not the right choice. So anyway, we got bought, turns out, because this really is going to be a walk down memory lane for me. We got bought by Sun Microsystems, who were really at the top of their game in 2008, I guess, whenever that was. I still worked in MySQL consulting. And as a result of that, I got invited. I remember when Sun was the .dot and .com back in the day. It was a lot of fun. I'm really old. I got invited to an internal sales storage conference because I was the database consultant with the new company they just bought, and so they wanted to talk about, like, what are all the .coms doing? What are all the Web 2.0 startups like? How can we sell them better storage for these database things? And they had this beautiful. I'm talking like Sun could make some hardware that was gorgeous. It was a full rack storage integrated solution with several Spark boxes in it and all these disks, and it had like a chimney in the middle, for heat, whatever. And it was. I wish I had one. Like, it was really cool. And I got to walk up in front of them and say, so no one's going to buy that because it's really expensive, and they're all going to the local store and just buying the cheapest thing that they can possibly buy. And the storage guys were just crushed. They're like, what? But look at how awesome it is. I'm like, it's too expensive. Like, everybody's doing database scale out. Like, they're not buying a giant database box. They're buying 100 database boxes, and they're not going to buy 100 of these. So that was a lot of fun. So same lessons. Simple is better than complex. Use cheap servers, right? It's all about scale out. Which leads me to the next piece of my personal walk down history lane is we forked MySQL after being bought by Sun. A group of us went over in the corner and did a fork of it called Drizzle. We updated the C++ some, it's microkernel design and whatnot. I think that this was probably what the executives at Sun were thinking. We just bought a company for $1 billion. Let's definitely fork it. It's what they did with NFS products. I think they had 8 parallel NFS teams working on things that never got delivered. It's maybe not much of a surprise that they're not around anymore. I have no idea why they paid me to work on this, but it was fun. It was kind of great. Our tagline was database for the cloud, which is sort of why I'm getting to this at an OpenStack thing. What a lot of people thought we meant by that was that it was going to like magically auto-scale, right? And you're going to have a database with like hundreds of little things, and just, elves are going to move your data around violating the speed of light, and it's going to be cloud magic, which is, it turns out, not possible. I haven't found the elves yet. The speed of light applies to all of us, and whatnot. What it meant for us is trimming down, making things simple again. MySQL had gotten kind of big and bloated, so we did things like deleting trigger and stored procedure support, because it turns out if you're going to do a scale out thing, for the love of God, don't use triggers or stored procedures, because you just put execution CPU intensive logic into the hard to scale piece of the puzzle. So got those out. Killed the 3-byte int type that was in MySQL, because that works really well in processor alignment. That extra byte in savings is gonna really pay off for the fact that the processor itself just can't handle the memory. We did things like sensible default, so you could actually run a Drizzle server without having to write out a config file, right? Like, to start up a MySQL, you've got to have a whole bunch of data directories and stuff pre-populated, and got rid of all that type stuff. We moved the data dictionary into the InnoDB table space, which I mentioned because one of the MySQL crash scenarios is if you crash in the middle of a DDL operation, essentially you need a two-phase commit between the FRM file that has the specification of the table and the actual table definition inside of the InterDB table space. InterDB itself is a transactional data storage engine, so you can just write the definition into the transactional data storage engine in the first place, rather than using the file that was there from when this was a project in somebody's bedroom. So things like that. But these are all things that allow you to work with the database in a smaller, simpler, less error conditions. All of those are things that are important for cloud workloads, right? It's that it fails quickly, or it fails cleanly, or it doesn't fail. Things of those nature. So also, incidentally, our development process in Drizzle happens to be the immediate ancestor of OpenStack's gating process. So if you are ever annoyed by some of the aspects of that, you can blame the team at Sun that got paid to work on a database fork of MySQL for no reason, because we did some things. Anyway, one of our favorite things to do in Drizzle was delete code, because one of the best ways to remove bugs from software is to delete code. It's possibly one of the most fun. We get really excited about negative source lines of code contributed to the project. Like, I've ripped out 100,000 lines of code this week. I've really been successful and productive. It turns out that we're not alone. So Doug McElroy was on the original Unix team at Bell Labs, and he was doing a talk in 2005, and basically said this. We sat around saying, like, what else can we rip out? Like, not what features can we add, but like, what can we go delete? Maybe the design of this isn't good if we've got to have all of these option flags over here. We need to rethink what the thing is. So simplify, squeeze things down. He also, in 1978, wrote out some things about the Unix philosophy. Like, what is it that we're doing with this Unix thing? And I'm not going to narrate all those, but it boils down to, have simple programs that do simple things that communicate with each other. Which, if you've been following the recent trends, people seem to have reinvented recently and called microservices. But that's what you do when you don't bother checking history. We've been writing. It's not a new thing. It's just called writing good software. It's how you design things to work well. It's possible that we've gotten too used in the industry to giant, bloated, horrible, huge Java app things from enterprise IT departments that have been outsourced. The other thing that Kernighan and Pike said in Unix programming environment, I think, is sort of right to that point and right to why microservices have become so popular with people, right? It's the same reason that Unix worked well for people in the first place, is the power of the system is in the relationship of the pieces fitting together, right? It's not that you wrote this one awesome program, it's that you wrote lots of simple programs and then you combined them in interesting ways. And you can really building block things out. And I think we're seeing that take things. So when we talk about cloud native, we're talking about a redefinition of Unix, but for the modern era, I guess. But it's an architectural and operational approach. It assumes cloud. It assumes failures. There's people who assume it has to be containerized. I don't agree with them, but that's fine. We can do that. Lots of things about microservices, which is all great. Like these are all good things. There's people who do things like, I'm going to write out some lists for how to write a good cloud native application, which is wonderful. You should have lists. It turns out that the Unix guys had lists of how to write a good Unix application, and in between the Unix folks and the cloud native folks, Eric Raymond had a really nice list of here's how to write good software, and lists are good and they're nice things. So that's great. I don't really like 3. 3 says that you should do all of your config from environment variables, which is insane for anybody that's ever actually run a production system. You don't want all of your config in environment variables. That's stupid. I use config files when they're necessary, and I use config management to manage them. Thank you very much. Whoops, sorry. I'm bad. I don't like the cloud native people. Stateless. All of your cloud native things are supposed to be stateless. All of them. Everything you write should be stateless. So please, back that database right up onto DevNull. It'll be great. It is web scale, of course, as we all know. So I'm not really sure how you're supposed to do data storage, except I think what you're supposed to do is you're supposed to use the nice vendor lock-in features of the cloud to store your data, because then you're not writing it in your evil stateful application. All your apps can be stateless, because we never want to store state anywhere. So if you obviously haven't seen the MongoDB as web scale cartoon, I highly recommend it because it's hilarious, even if a little dated at this point. But in any case, please go watch that before writing all of your completely stateless cloud-native applications. This is a quote I pulled off the side of a building for right before OpenStack Days Prague last year, and walked in and like, I am going to give a Václav Havel quote to a bunch of Czech citizens in Prague. I'm an idiot. But I really like it, and I think that it applies to us in the IT industry. We keep adding abstraction layers, we keep adding frameworks, and less of us know how anything works at all. People are just copycatting each other and sort of going blindly down the path. And that's fine, right? Not everybody's going to understand everything, but it seems to bother us all less, right? People are not annoyed that they don't understand how the stack works. It doesn't really seem to bother anybody that, I mean, really think about it. You got your containerized app on top of a VM, on top of an operating system. There's a systemd somewhere in there doing God knows what. Like, do you have any idea what's actually happening in that system? No, none of us do. It's gotten too crazy, and that's a problem, because how do you debug that when it breaks? How do you deal with that? How do you deal with that sanely? And that's a thing I'd like to see us think about. So the same guys that did the original Google paper that everybody knows and loves have a nice long follow-up thing from 2009, and there's actually a second edition of this that I think they released a couple years ago, which is kind of fantastic, where they say, you know, all these little pizza box servers, they're cool and everything, but actually, you really want to think of the entire data center as one computer. So it's just because like the what's his face, Louise is one of the people that like really worked on getting multi-core processors to work in the first type, which was crazy parallelism. Oh my God, you've got multiple cores on a processor. What are you thinking? And this is extending that. It's like, well, screw multiple cores. We're just going to have I'm going to have a computer with hundreds of thousands of cores. It's just going to be a data center, and it's going to have lots of independent power units in it, and whatnot. Which is really it's a nice thing. Sort of the next step in that puzzle. The thing is that one of the other things that was really great about Unix is that it was a portable operating system, right? The general way that people did things at that point in time is they'd build a new computer, and they'd build a new operating system for that computer. And if you bought a particular computer from one of the manufacturers, which was probably digital, you would learn the operating system for that computer. If you got a different computer, you'd learn the operating system for that, or it might not have an operating system, you might have to write one in assembly language, which I'm really glad we don't have to do that anymore. And Unix, in deciding to write itself in C, which itself was a higher level, C was the high level fancy programming. It was like the Python of its day. We were like, I can't believe you're going to write an operating system in C. That's completely like irrational. But they did that so that even though they designed it for the specific DEC computer, porting it to other computers was a reasonable thing to do, and that happened, which is kind of a revolution for the world of computing, all the way back in 1978, when we still had revolutions. So ultimately, all of this rambling is sort of to get to the question: if the data center is the new computer, right? If that's the unit of currency that we're working on, then the power of OpenStack is to be a portable operating system. It's to be the Unix. I got roped into doing a OpenStack as Linux talk at LinuxCon Europe several years ago, which was a bad idea. But there's a real thing here. It's the idea of having a portable thing that can run on different computers from different manufacturers, right? Because like you have MVS for IBM 370, but MVS isn't really going to run on my laptop. Thank God. Thank God my laptop is not an IBM 370. That would be insane. AWS, it's an operating system written for a specific company's specific proprietary computer. if the computer's a data center, right? Data center's a computer. Like they've built a proprietary piece of hardware, which is however they're stamping out data centers, and they've written an operating system for it. Cool, right? Same thing with Google. Google Cloud is an operating system written specifically for Google data centers with the computer that is a Google data center. So if, by their reasoning, if cheaper commodity servers are superior to custom-built high-end hardware and fancy overpriced Sun boxes, then I would think a collection of us having our own commodity data centers with a portable, shared, open, free operating system running on them is ultimately the only viable choice, right? Why in the world will we go back to the 60s and 70s in terms of computing architecture and the way that we interact with things and go into a one or two vendor ecosystem? Are you kidding? That's insane. Everything about it is literally absurd. The idea of putting any of your programs into such a system by choice, you gotta have your head examined. It's the most absurd thing I've ever heard in my life. So anyway, Linux won the battle for server single computer. I'm sure I hear there's still people running Windows Server. I'm sorry if you're one of them. That's silly, but it's on my phone. It's on all of the servers and all of the data centers. For us, it's time for us to win the battle of the warehouse-sized computer and make sure that we've got free and open things in the services realm and to do all that. So anyway, that's my long rambling walk down memory lane of Unix. I hope that you can manage to eat lunch after dealing with that. So anyway, thank you very much.
Thank you so much for that, Monty. So, any questions for Monty then? Does anybody dare?
The problem is that somebody's gonna be like, you got those historical references wrong, man. Like, that's not what he was saying at all. I'm gonna be in trouble.
Hello.
Hello.
Thanks a lot for your talk. It was enjoyable.
Woo!
I would like to know, when you interact with a customer and who asks you to deploy their systems to the cloud, what would you answer if he says, but AWS is the market leader, why shouldn't I use that?
Digital was the market leader. I think that putting all your eggs into a single vendor basket is irresponsible as a business. You are at the whim of Jeff Bezos deciding to throw a chair at somebody, and whatever the ramifications of that might be. I think it's an insane thing with all of the choice that you've got in front of you to lock yourself in to one leader. And they're the market leader, but they're also in a position that they physically cannot become the absolute answer for the world, because there are places where putting your data into the data centers run by a company that's under the aegis of the US or the NSA is not feasible, right? So I don't know, if you're in, say, China doing government things, you're gonna put your stuff into Amazon data centers? Don't think so. You're gonna, I think that there's finally been something worked out with the German government with data sovereignty laws for some things, but there's other things where no. So it's a place where having local regionalized choice is really important, right? And depending on the industry, depending on the what the workloads are, who the customer is, the choice of being able to have private cloud or public cloud or hybrid, any of these things is a really essential choice for them to have for their business. I mean, I can go on about the sort of open source, and I do strongly believe in that, but for the business reasons, locking yourself into that is quite literally stepping back to the world where everybody's financial transactions had to go through an IBM mainframe, right? People are happy when they get out of those things, or the people who got themselves into an Oracle contract at some point and then realize that Oracle won't let them buy less licenses, because if they buy any less licenses, they'll stop selling them any of the licenses. So one of the most brilliant sales tactics anybody's ever come up with. But these are situations that the industry's gotten itself into a couple of times now, and we're in a position where people are madly, happily rushing right back into the maw of the dragon. You're like, you just, oh my gosh, you're finally out of being locked into these things we just spent the last 20 years on undoing. You're going to do it again. So yeah, they're the market leader for now. But the thing is that collectively, It's like, does anybody know who the market leader for white box throwaway PCs is? I certainly don't, because it doesn't matter, because there's 20 of them, there's 30 of them, there's 50 of them. The market leader is there is no market leader, right? The market leader is that there's an open market that we all get to participate in. So I'd say that there being a single market leader is a terrible position for a customer to be in. They don't want to be in that position. They want the ecosystem of companies to all be able to think. So they go and get some things from, I don't know, they buy some stuff from us at Red Hat, and then we piss them off, and they go and they call Allison. They say, hey, can SUSE come in and take over this? And that puts the customer in a much stronger position in basically every single way conceivable. Other than, yeah, it might be shorter, it might seem quicker in the very short term. Oh, look at all of the services that Amazon's got, all these advanced things. Every single one of those is a nice way for them to lock your data into their platform. Yeah, something like that, probably with less waving of my arms and dancing around, and maybe with better words, but generally speaking, I might actually do exactly literally that, because I can't stop myself.
Speaking of...
Oh gosh, no, it's Florian.
Speaking of HA,
yeah.
Would you agree that we did kind of terribly in the not reinventing the wheel space when it came to HA in OpenStack? And if so, how do we not repeat that mistake?
There's like a triple negative in there. So actually hang on, take the back to the, which piece of HA, like in what context?
Oh, well, like the general context of
making
OpenStack highly available. We went through a significant number of dead ends before we got people in there that actually pushed it into the right direction. And I'm talking years.
Yeah.
Right? And we're seeing something similar, we're seeing similar discussions still ongoing, where those same people now need to go in and kind of yank the discussion back into the right direction, because it would otherwise go off in the wrong one.
Yeah. So
why does that happen, and what can we do to improve on that?
I think so. I think Allison touched on from my end, touched on one of the pieces, right? And I'm happy to see the direction happening that she mentioned, which is that the people who are good at HA, the people who are good at those sorts of things, they're the operational people, right? They're not the first wave developer folks. They're the folks running it, and they're not running it until it's at a certain point, right? Like, we weren't doing HA consulting engagements with MySQL in the 90s, because it hadn't gotten there. There hadn't been enough shared corpus of knowledge to build up those practices. So I think it took a long time because the people working on it weren't necessarily the people running it, or in the couple of cases where it was, those people that are running it weren't in a position they didn't have the bandwidth to go in and engage on a deep architectural level. As we're seeing more and more engagement from the users rather than the vendors, I think that we're starting to see those conversations happen. And I think that this same pattern happens in other young and fast-growing projects. Like, you come in and you're like, wow, you're making that same, God, we made that mistake 10 years ago, we made that mistake 5 years ago, and look at you, you're just coming right along and not learning from any of our mistakes and making the exact same ones over again. Because it's not fun. It's much more fun to go to the coffee shop and I don't know why you're drinking beer at a coffee shop, but like drink beer and code and like feel really cool. It's less fun to read white papers and research and to look into what other people did and to learn from their mistakes. That's the kind of process rigor that us older, crustier professional folks do, and really annoys the folks who are like, wow, I wrote 5 new services this week. And you're like, yeah, well, they're all going to fail next week, and that's cool, because that's how you learn, right? That's how anyway, I'm babbling now, but. I'm always babbling. That's how that works. But yeah, I think it's a tricky thing. I would love to figure out how we could start new projects in such a way that they didn't all have to go through the same learning curve, right? So that it's not the new shiny 80% done, and then we spend the next 5 years cleaning up the next 20%. But I have no answers.
Thank you so much, Monty. We got to chase you off the stage now.
Excellent.
Thanks.
All right. Thank God. Thank you. Woo-hoo.